Cosmologists have zoomed in on the smallest clumps of dark matter in a virtual universe, which could help us to find the real thing in space. An international team of researchers, including Durham University, UK, used supercomputers in Europe and China to focus on a typical region of a computer-generated universe. The zoom they were able to achieve is the equivalent of being able to see a flea on the surface of the Moon. This allowed them to make detailed pictures and analyses of hundreds of virtual dark matter clumps, or halos, from the very largest to the tiniest. Dark matter particles can collide with dark matter antiparticles near the center of halos where, according to some theories, they are converted into a burst of energetic gamma-ray radiation. Their findings, published in the journal Nature, could mean that these very small halos could be identified in future observations by the radiation they are thought to give out. Co-author Professor Carlos Frenk, Ogden Professor of Fundamental Physics at the Institute for Computational Cosmology, at Durham University, UK, said, "By zooming in on these relatively tiny dark matter halos we can calculate the amount of radiation expected to come from different-sized halos. Most of this radiation would be emitted by dark matter halos too small to contain stars, and future gamma-ray observatories might be able to detect these emissions, making these small objects individually or collectively visible. This would confirm the hypothesized nature of the dark matter, which may not be entirely dark after all. Most of the matter in the universe is dark, apart from the gamma radiation they emit in exceptional circumstances, and completely different in nature from the matter that makes up stars, plan. The universe is made of approximately 27% dark matter, with the rest largely consisting of the equally mysterious dark energy. Normal matter, such as planets and stars, makes up a relatively small 5% of the universe. Galaxies formed and grew when gas cooled and condensed at the center of enormous clumps of this dark matter, so-called dark matter halos. Astronomers can infer the structure of large dark matter halos from the properties of the galaxies and gas within them. The biggest halos contain huge collections of hundreds of bright galaxies, called galaxy clusters, weighing 1,000 trillion times more than our Sun. However, scientists have no direct information about smaller dark matter halos that are too tiny to contain a galaxy. These can only be studied by simulating the evolution of the universe in a large supercomputer. The smallest are thought to have the same mass as the Earth according to current popular scientific theories about dark matter that underlie the new research. The simulations were carried out using the Cosmology Machine supercomputer, part of the Dirac High-Performance Computing Facility in Durham, funded by the Science and Technology Facilities Council (STFC) and computers at the Chinese Academy of Sciences. By zooming in on the virtual universe in such microscopic detail, the researchers were able to study the structure of dark matter halos ranging in mass from that of the Earth to a big galaxy cluster. Surprisingly, they found that halos of all sizes have a very similar internal structure and are extremely dense at the center, becoming increasingly spread out, with smaller clumps orbiting in their outer regions. The researchers said that without a measure scale it was almost impossible to tell an image of a dark matter halo of a massive galaxy from one of a halo with a mass a fraction of the Sun's. Co-author Professor Simon White, of the Max Planck Institute of Astrophysics, Germany, said, "We expect that our research sheds light on these small halos as we seek to learn more about what dark matter is and the role it plays in the evolution of the universe." The research team, led by the National Astronomical Observatories of the Chinese Academy of Sciences, and including Durham University, UK, The research was funded by the STFC, the European Research Council, the Chinese Academy of Sciences, the Max Planck Society and Harvard University. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you new tech videos. Thank you.